like to obviously thank Ilse for inviting me over to the meeting. This IAFP meeting in the summer is always a focus for me, and it's great to be back and meeting so many old friends and making some new ones again. Okay, before I start, I guess an apology. You're looking at a simple food microbiologist. I'm not a risk assessor, but I spend much of my time assessing risks. What I'm going to talk about in the context of this zero tolerance symposium is looking at performance standards of different types, but ones which will hit my goal of trying to make food safer and reduce the level of food poisoning that people see when they're out there. When I came to write the talk, I came to the title of the symposium, and zero tolerance obviously hits there as a big part of the title. Now, it's not a term that's used greatly in Europe. We have a negative or absence in 25 grams criteria, but the term zero tolerance is an interesting one. And the first thing I did when I started writing the talk, or began to write it, is thought, well, what's the definition of zero tolerance? And after a fair degree of searching on Google, I actually managed to find a definition. And this is a definition that came from a National Research Council committee review on scientific criteria and performance standards from 2003. And they defined zero tolerance as, what it says here, a lay audience perception of the absence of a hazard that cannot be scientifically assured, but is operationally defined as the absence of a hazard in a specified amount of food as determined by a specific method. Now, it's a long definition, which sort of indicates it's a complex term, but there's two definite parts to it. First part is that to a large proportion of people, zero tolerance actually means the absence of the hazard and zero risk, which obviously can't happen. But a lot of people think that's what it means. The second part, I think, is the more microbiological definition, which is actually what it means is the absence of a particular hazard in a 25 gram or more specified amount of food material. Does that mean its absence in all of the food? No, of course it doesn't. So it's a complex definition meaning different things to different people, but not doing probably what most people think it should. So, where does that leave us when it comes to performance standards? Well, I'm going to really talk through the rest of the slide about two types of performance standard. One which people may consider the usual one, which is via microbiological criteria. And secondly, performance standards via process criteria or product criteria, which probably is a better way to go in most cases. Via microbiological criteria, I'm not going to go down the route of talking about listeria absence or whatever it was, less than 100 per gram, as we talked about yesterday from a European versus a US perspective. I'm going to talk about how criteria have been used in the UK to tackle a particular problem of Campylobacter in poultry. Now, the criterion that's been used is not a zero tolerance criterion, it's not an absence criterion, it's a numerical criterion that has to be met or should be met. And I'll talk a little bit through about why that was used, what the problem is, and what some of the outcomes have been to give an indication of how a criterion can be used to give a very positive response and an improvement in food safety. Background. As in most countries, the biggest single cause of food poisoning in the UK every year is Campylobacter, causing various types of infectious intestinal disease. We have somewhere around about 60 to 65,000 reported cases in the UK every year. The main cause is contamination of raw poultry, and raw poultry being either undercooked or causing cross-contamination in the kitchen environment and then causing issues, cases or outbreaks. The bottom table is data collected at various times by the UK Food Standards Agency about the prevalence of Campylobacter in retailer purchased whole birds. So this is chickens as you would buy them in the shops. And in 2005, about 70% of all birds that you bought in the shops were contaminated with Campylobacter. And it didn't change over the next 10 years or so. We had this level of about 70% of all poultry that you purchased in the retailer contained Campylobacter. And the challenge that faced our competent authority, the Food Standards Agency, is how do you try to decrease the amount of food poisoning coming from this source in a relatively short period of time. And the way they did it was to use a criteria-based approach. They knew, because of the levels of contamination and the ways the birds were being reared, that it really wasn't feasible to introduce a zero requirement, a not detected requirement. It just wouldn't work. But they wanted to introduce something that would help bring those levels down. Now, what they did, and I stress again, this is a slight deviation from the title of the talk, wasn't introduce a standard. This wasn't legislated. They introduced guidance. And they introduced some guidance and then tried to encourage producers and retailers to take appropriate action to reduce prevalence and levels. And I'll go through the way they actually did that. What they did is they looked at the levels that they were finding on various birds through surveys, and they created 3 criteria sets: less than 100 per gram, 100 to 1,000 per gram, and greater than 1,000 per gram Campylobacter. And they decided, and they did this through a series of modelling to see what would happen to food poisoning levels, to attempt to reduce the number of birds that fell excuse me, into the greater than 1,000 per gram set. And they modelled the fact that if they reduced the number contaminated at post-slaughter from 27% at 1,000 per gram down to 10%, then that would be about equivalent to 7% at greater than 1,000 per gram at retail. And they modelled that to mean that potentially that could reduce the levels of illness in the UK by somewhere around 50%, illness due to Campylobacter. So that was the theory behind what they were trying to do. How do you set about doing that? How do you set about, without introducing a standard piece of legislation, how do you do it? Well, they put in place through a public health agency a large-scale surveillance, and that ran over a 3-year period. They were publishing the results annually, actually more than annually. They were producing results about every 6 months. And what they did was they actually produced those reports and published them. They published them on the internet, and they introduced what they would call a name and shame policy. So all of the retailers that they tested were named with the percentage that was due to them causing greater than 1,000 per gram Campylobacter. Introduced lots of work. Obviously the retailers and the producers, who didn't really want to be associated with being top of the list, did a large amount of research work on how to reduce the levels of Campylobacter in the poultry that they were selling. And over the course of time, this slide, and you can see on the top table, the actual percentages of poultry at greater than 1,000 per gram over a 2-3 year period. And it started in 2014 at about 20% of all poultry at greater than 1,000 per gram, and the reports at the end of last year were bringing it down to about 7% in 2016. Interestingly, as well as bringing down the level at greater than 1,000 per gram, the prevalence also came down from about 78% down to 56%. So this was having the effect of reducing those levels. The bottom graph was taken from the FSA's website, the Food Standards Agency website, in March. And what this was trying to do was then to put into perspective what the public health significance of that reduced level actually was. And what you can see in the orange dots is that retail survey, the percent above 1,000 per gram, gradually dropping down to about 7%. And what you can see on the blue bars is the lab reports of Campylobacter food poisoning over the course of that 3-year period, which is showing a reduction. Now, of course, you can't be absolutely certain that reduction is due to levels of above 1,000 per gram dropping, but there's some evidence there that we were getting about a 10,000 case per year drop in the number of reported cases of Campylobacter food poisoning over that period of time. They already know that the underreporting level in the UK for Campylobacter is about 1 to 9, 1 to 9.3 in fact. So for every case reported, there's about 9.3 cases that aren't reported. So they're coming out to say, well, actually, this could be reducing the level of foodborne illness due to Campylobacter in the UK by around about 90,000 cases per year by introducing not a standard, a guideline, by introducing some good reporting that publicises good and bad practice, and bringing down the level of food poisoning. Now that's the power of a performance standard based on microbiological criteria and not a zero tolerance criterion. It's not a standard, it's a guideline, it's not a standard at all, it's never been written into legislation. The reporting method they chose had a great effect. It appeared in newspapers, it appeared on the television, it was widely circulated on the internet. They actually introduced and encouraged people to take part in this by saying you'll get shown up quite well publicly if you don't start to comply and improve the levels that you have. It generated a huge amount of research on how to reduce the levels of Campylobacter in poultry. And it made additional benefits. Because it kept appearing in the press, it made the public far more aware of the issues of Campylobacter in poultry and about handling practices and cooking practices. And it introduced other things like the bottom there. A lot of the retailers went forward to create things like cooking bag chickens, where they would actually package the chicken in a heat-resistant bag that you just took, put straight in the oven and cooked. So there was less chance of cross-contamination in the kitchen environment. So whether that reduction in levels was the whole story or whether it was additional things that happened like cooking the bag and consumer perception, improving handling practices in the kitchen, we don't fully know. But there's no doubt that introducing that type of performance standard improved food safety due to Campylobacter. And it's an interesting way that can be used in order to get that positive effect. That standard, or that guideline, now moves on to become a standard. This is an excerpt of a change to the European Union Microbiological Criterion document, Regulation 2073/2005. This will come into force in January 2018. And it's not a food safety standard, it's a food hygiene standard, but it introduces a requirement to achieve less than 1,000 per gram Campylobacter on raw poultry. And what you see here is essentially a sampling plan where the number required testing is 50, that's C. The amount that you can be outside of the criterion is 20 at the moment. The limit is 1,000 per gram. It applies to carcasses after chilling, and you don't have to recall if you don't meet the requirements. This is a hygiene criterion, not a safety criterion, but you do have to look into ways of improving slaughter practices and hygiene if you breach this particular standard. And the other thing is it's a shifting standard. It comes into force in 2018 with C being 20. From 2020, that number C comes down to 15, and from 2025, it comes down to 10. So it's a continual improvement standard, reducing the level that you can have above that 1,000 per gram standard. So again, not legislation, not a standard at the moment, but being introduced into EU legislation as of January 2018. Okay, moving from criteria-based standards to process-type standards. This is another way we can attempt to reduce the levels of microorganisms in various food products. And these are probably, my feeling, better than the criteria-based standards. These are systems which can be shown to reduce or maintain a pathogen to an acceptable level in a food product. That acceptable level, you would say it's the food safety objective. If you know the acceptable level and you know the potential amount of the hazard that's in your food product, you can produce some form of criteria for the process that you wish to use. The process standard might be the application of an external process like heat and time. A product standard might be attaining a particular parameter with the food like a pH or a water activity. But it gives you the chance to actually create a product in which the level of microorganisms is below a set requirement. What you need to know is the acceptable level of the hazard in the product. What are you willing to accept? You need to know the maximum level that might be found in the ingredients or products that you're going to produce or use. And then you can devise the appropriate process or product criterion to reduce the levels of that hazard to the acceptable level. There are numerous examples of these types of standards around. Going back to the 12D log reduction process for Clostridium botulinum in canned foods, there's many that lie in US regulations from FDA and USDA, in fact. 5 log reduction processes for juice, the 68 degrees for 15 seconds for burgers for a 5 log kill, various milk pasteurization treatments around the world, and the salmonella compliance from FSIS pertaining to fermented meats, a validated 5 log reduction process. So these are around everywhere, and you'll find them in many other countries as well, and they work really well. There are a number of issues to consider and to think about when introducing this type of parameter. The first might be, depending on where you live in the world, the level of hazard reduction might vary. In the US, generally you seem to go for 5 log reduction processes. In Europe, we tend to go for 6 log reduction processes. Just the way it is. There's other parameters that you need to consider, and the table here is one that has vexed us in the UK on numerous occasions. These are log reductions, calculated log reductions due to heat for Listeria monocytogenes and E. coli 0157 that come out of standards that we have. It's a 6 log reduction process, and you can see at the reference temperature of 70 degrees for 2 minutes actually gives a slightly greater than 6 log reduction for both L. mono and E. coli 0157. When you start to move away from that, if you use calculated time temperatures, you start to see differences. And if we move, for example, to 60 degrees core temperature, that would be equivalent to 43 minutes for L. mono, but 93 minutes for E. coli 0157. Why? Because the Z values are different for both that were chosen to do this. So you need to also have an understanding a little bit more about the parameters that relate to the hazard, so you can design the right process to achieve the level of reduction you need. When we look at parameters related to the food, things like pH, water activity might need to be considered as well. And a little a note at the bottom of there, which is slightly exaggerated, but it makes a point. If you look at the D value for salmonella, in fact, in this case, in brain heart infusion broth at 62, it's about 24 seconds. If you look at the same organism in a low water activity product like wheat flour, you might be talking about a D value of 14 hours. So you need to know something about the product parameters and the parameters relating to the hazard before you start to set these processes for getting down to the right level. Things to note, some criteria are specified as a process to be given, X degrees C for Y minutes, and you need to therefore validate the time and temperature within a particular process that you're going to use in particular equipment. And some criteria are specified as a log reduction. So you need to achieve an X log reduction in order to meet the requirement. And if you're going to do that, you'll need some form of full microbiological validation, probably using a surrogate or the target organism inoculated into the food in order to look at if you can actually achieve that. I want to now move on to another criterion or a parameter-based system that we've got being introduced at the moment in the UK. And it shows how you can use microbiological criteria and process criteria within the same risk reduction environment with the same hazard in order to achieve a safe food product. Now, the start of this particular piece of work began with an EU, a European Union working group on microbiological criteria. And they were debating guidance on actions to take if Shiga toxin-producing E. coli was detected in various types of food product. The EU guidance actually stopped about a year ago because they couldn't get a consensus opinion between the various member states on the best way to go to achieve this. But actually the UK have still got that guidance, made some changes to it, and are moving it forwards to give guidance to the Food Standards Agency and enforcement officers in the UK on what actions to take should they find Shiga toxin-producing E. coli in different types of food. And I'll talk through how that moves forwards. And the way it operates is to actually split the food types into two risk profiles. And these are very simplistic risk profiles, but no hard and fast risk analysis been done on this. And the two risk profiles that they've used are shown on the slide. Ready-to-eat foods and those foods that are likely to be consumed less than thoroughly cooked. So reheated products that aren't going to get a full antimicrobial, if I could use the term, process. So that's the first group. Second group is foods to be consumed after a process that will remove a Shiga toxin-producing E. coli risk. Cooked food products, things that are going to be cooked at some point by the consumer. If we look at the food profile one, these are foods that are going to be essentially ready to eat and not properly cooked. Okay, if that type of product was tested and detection of a Shiga toxin-producing E. coli was found, then the action would be to withdraw that product from the market. So from that you can take it, there is a zero tolerance for Shiga toxin-producing E. coli in ready-to-eat food products. Doesn't matter what serotype, if it's there, it's removed from the market. So that's the first criterion or guideline that's put in place. Food profile 2, this is for non-ready-to-eat foods. And it goes a stage further, because first of all, it's not simply saying all Shiga toxin-producing E. coli. It's saying for confirmed presence of what we would say are the high-risk group of serotypes of Shiga toxin-producing E. coli. Slightly different from the group that you have in the US by maybe one or two serogroups, but these particular ones are the ones that cause most outbreaks of food poisoning in Europe. If you find the presence of one of those serogroups, the next thing that would be looked at is the product sufficiently labelled for a cooking or a treatment before consumption that will remove the Shiga toxin-producing E. coli risk. So it would be, can we see a way that the consumer is being given the right information to remove this hazard from the product through a cooking process? If the answer is yes, there's the correct labelling on there, it's clear the consumer would cook the product fully before eating it, then that product could be left on the market. If there's a consideration that the labelling isn't good enough and there's a chance that that product would not be consumed in a fully cooked state, then that product would have to be withdrawn from the market or not distributed and could be used in other ways, but it couldn't be left on the market in that state. In both cases, there's a requirement to investigate the source of the problem and to put in place further control measures. So you can see this is a mixture of criteria and process control in trying to reduce the E. coli 0157 hazard. Some conclusions. Personally, I think zero tolerance to be a fairly overused term. It means very different things to different people. It certainly doesn't mean that there's no risk in a food if you operate a zero tolerance policy. We've heard that this morning. Doesn't mean zero risk. The use of well-defined microbiological criteria, standards or guidelines, if they're properly implemented, can drive improvements in food safety. That's clear from the Campylobacter work in the UK. End product testing, actually, it's a very crude tool, it's a very basic tool. It can never assure actual safety. We often get people coming to us talking about, can I increase my sampling plans, increase the number of samples tested to get more safety in my product? I don't personally believe you can ever test a food safe. Unless you test every single piece of food you produce, you will never test a food safe. End product testing is a tool that gives you an idea to verify the actions you've taken in producing the food to have safety. And that's why testing can never really give you absolute safety, if it exists. Process and product criteria are actually really good tools if they're well designed. It requires a knowledge of the food, it requires some validation work, and it requires an understanding that you need good hygiene after the application of any process to maintain the standard that you've got and to prevent recontamination. And it also is possible, from the Shiga toxin-producing E. coli example, to mix performance standard types, criteria, and process criteria together to achieve the desired outcome. I hope that's given you an insight into my thoughts about zero tolerance procedures. Thank you very much.